Assalamualaikum and good evening. My name is Hareez Imran bin Hisham. I am from Universiti Teknologi Malaysia and I would like to present the topic of geochemical analysis of reservoir fluids. So, this is a table of content of my presentation, which is include introduction, types of reservoir fluids, key aspects, techniques of geochemical analysis in reservoir fluids, example and case study, challenges and limitation, and also conclusions. So basically, what is geochemical analysis of reservoir fluids? So geochemical analysis of reservoir fluids involve studying the composition and isotopic characteristics of crude oil, natural gas, and formation water to gain insights into the history and characteristics of subsurface hydrocarbon reservoirs. So basically, the geochemical analysis in reservoir fluids refers to the study of the chemical composition of fluids found in subsurface reservoirs, such as oil and gas reservoirs, and this analysis provide valuable information about the origin, maturation, migration, and alteration of hydrocarbons in the Earth crust. So, geochemical analysis is crucial in the field of petroleum exploration and production, helping geoscientists and reservoir engineers to understand the characteristics of reservoir fluids and make informed decisions about resource development. So, this is the sum of key aspects for geochemical analysis. So one of it is composition analysis. So geochemical analysis involve identifying and quantifying the various components present in reservoir fluids, include hydrocarbons such as crude oil and natural gas, and non-hydrocarbon components such as water, sulfur compounds, and so on. So next is source rock characterization. So uh, basically, geochemists study the molecular and isotopic characteristics of organic matter within source rocks. So by analyzing the specific biomarkers and organic compounds in the source rock, they can identify the type of organic material that contributed to the formation of hydrocarbons. So next is the maturity assessment. So basically, for this one, uh, the thermal maturity is a crucial factor in understanding the stage of hydrocarbon generation. Basically, geochemical analysis involve measuring parameters such as the ratio of saturated to aromatic hydrocarbons, as well as the presence of specific maturity indicators. For an example, is with renite reflectance. So these indicators help estimate the level of thermal maturation the source rock has undergone. So next one is migration pathways. So basically, for this one, the geochemical traces such as stable isotopes and specific biomarkers can be used to trace the migration pathway of hydrocarbons. So these traces help to determine the direction and extent of fluid movement within the subsurface, aiding in the understanding of the migration history of hydrocarbons. So the last one is fluid alteration. So basically, reservoir fluids can undergo alteration due to microbial activity, water washing, or other chemical processes. So basically, geochemical analysis helps identify the extent of this alteration by examining change in the abundance of specific compounds and isotopic ratios. So for the next slide, shows the various techniques that involve to examine the composition, properties, and characteristics of hydrocarbons and associated fluids. So some of the techniques is gas chromatography. So this is the most famous technique that we use in our industries. So the gas chromatography is widely used for separating and analyzing individual hydrocarbons and other volatile compounds in reservoir fluids. So it provides information about the distribution of different hydrocarbon components. So next is gas chromatography and mass spectrometry. So this technique combines gas chromatography with mass spectrometry, allowing for the identification of individual compounds based on their mass spectra. So it is particularly useful for identifying biomarker and other molecular indicators. So next one is liquid chromatography. So this one is employed for separating and analyzing non-volatile compounds in reservoir fluids, including heavy hydrocarbons and polar components. So it is different for gas chromatography, which is for volatile compounds, while liquid chromatography is for non-volatile non-volatile compound. So next techniques is stable isotope analysis. So this one is can be analyzed to provide information about the origin and thermal maturity of hydrocarbons. So isotope ratio can also help in source rock identification. And next one is pyrolysis. So this one involves heating the rock or fluid sample to high temperatures in the absence of oxygen. So the resulting of pyrolysis products can be analyzed to understand the thermal maturity of organic matter and identify the potential source rock. And the last one is nuclear magnetic resonance. So this one provides insights into the molecular structure and fluid properties, such as porosity and permeability within the reservoir. So it is particularly useful for understanding the distribution of fluids in porous rock. So there are other techniques too, but I just list six of it. So this is the example of picture for gas chromatography. You can see. So for this one, is the detection of molecular heterogeneity in reservoir. So basically, this picture shows that the difference in fluid compositions are detected with the help of data managing techniques, which use visual representations, such as this star diagram you can see here, and GCMS fingerprinting. You can see this one, or else. So basically, the result is the recognition in the set of analysis of oil families with close or identical chemical characteristics. So you can see there are results for correlation with principal components here, and also oil-to-oil correlation. So this is on the gas chromatography screen. So next one is case study. So basically, this picture shows the difference between production fluids and organic contents of reservoir from Abu Dhabi, Oman, and France. So basically, this fluid composition, which is less biased than the one determined on the produced fluid. So it will provide a more realistic material for PVT testing and alpha-tin or wax problem predictions. Additionally, evaluating the total reservoir organic content is the only way to detect potential production problems such as the occurrence of bitumen or pyrobitumen in the reservoir. So an example of such a situation is proposed on the figure beside figure 3, which is in this field, no difference was found between two oil samples. However, the first oil comes from a well where wax happened to precipitate during production. So the other one from a well where no precipitation occurred. So specific extraction procedure and identification of heavy hydrocarbons by high temperature gas chromatography was performed on the reservoir extracts prepared from the two different well cores. So the presence of wax was clearly recognized in the extracted associated with the precipitating oil wax, so access being almost to the other rock samples. So such analysis, which can be performed on core samples as soon as they are available, might be taken into account for the production strategies. So these are the uh, few challenges and limitations. So first one is sample availability and quality. So basically, the quality of sample is crucial for accurate geochemical analysis, and the process of retrieving samples from deep underground can introduce contamination or alter the fluid composition. Next is biomarker variability. So while biomarkers are valuable for source rock characterization, so their presence can vary due to factors such as microbial activity and alteration process. So next challenge is technological limitations. So basically, the availability and development of advanced analytical techniques are crucial for precise geochemical analysis. So basically, technology limitation may restrict the range of parameters that can be analyzed or the accuracy of measurement. And last but not least is the cost itself. So basically, uh, those the, those involved. So basically, geochemical analysis, especially those involving the advanced techniques, can be costly and resource intensive. So this may limit the extent of analysis or the number of samples that can be studied, impacting the overall understanding of a reservoir. And for the conclusion, basically, this analytical approach provides valuable insights into the origin, evolution, and characteristics of hydrocarbons, contributing to informed decision making across the exploration, development, and production phases. So, by employing a variety of techniques such as gas chromatography, mass spectrometry, stable isotope analysis, and others, geoscientists and reservoir engineers can achieve the following key objective or key aspect that I have presented before. So, the integration of geochemical analysis into reservoir studies plays a pivotal role in addressing challenges and uncertainties in the complex subsurface environment, ultimately supporting sustainable and efficient hydrocarbon exploration and production practices. So I think that's all from me. So thank you. This is my reference page for this slide. Thank you.